Hey guys, my name is Sandeep Patel. I'm the founder of Slotify.ca. In today's video, we're going to learn about array data structure. So what is an array? What are the different types of array? And the type of array operations. Let's start with something basic first. So let's ask the question, what is an array data type, right? So arrays are non-primitive data types, right? And they are a collection of elements, right? So what do I mean by collection of element? So let's say that this is an array. It has 10 different elements, right? So arrays are zero-based index, which means that the index start with 0, not with the 1. So that is a very tricky part. When you are working with the array, you should know that the array indexes are starting with index 0, right? So let's say there are 10 elements, and arrays are like stored in the memory back to back. What do I mean by back to back? Means that what I mean by that is that after 0 index it comes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll also learn about how they are stored in the memory, right? So in my previous videos I talk about how computer store different data types, right? So usually the computer has access to stack first, right? The stack, there are two type of memory. There's stack memory and heap memory. When a program runs, it creates two type of memory, stack and heap memory. And the computer has a access to stack memory first, right? So when you create an array, let's say this is an array, right? We create it and we name it as array, right? So it creates an label array in the stack memory, and then it stores a reference. What do I mean by reference, right? So actual, because arrays are non-primitive data type and stack memory only stores primitive data type or references, right? So the array can grow dynamically in the size, right? And that's the reason why they are stored in the heap memory, because heap memory is can grow in dynamic size, right? While stack memory is a fixed memory. All right, so let's say when you create an array of one with 3 elements, 1, 2, 3, right? So it is created in this heap memory with some address or pointer. So this reference is like a pointer to an address. So let's say that the first element is pointing to a memory address 1000, right? So what would be the next element? So every single element, they're stored in the memory. They're stored in the back-to-back memory, right? So let's learn how they're stored in back-to-back memory, right? So when this array is created, the first element, so let's say that first element is stored at hexadecimal value 1000, right? So this is the memory address for the first 0th element, right? So 0th element stored at this position. So what would be the memory address for the second element, right? So we will use this formula. So this formula is used to find the array in the next memory address, right? Okay, let's go back here. So let's use this formula. So what this formula says that the reference, which is the first memory address, in this case is 1000, right? And then you then add it, do an addition with the index. So the index that we're trying to access is the first index. So you put first and then into element size. So what is the size of the element? So that depends on the type, right? So right now we are storing numbers. So let's say the numbers has 4 integer, right? 4 bytes. Integer takes 4 bytes memory, right? So if we want to calculate the next address, so that would be hexadecimal 1000 plus we're trying to access the first index and the size is 4 byte, right? So which is equal to hexadecimal 1004, right? And if we want, let's say, a second index would be 0 into 1000, right? Plus second index times 4 byte for numbers. It could be different for strings. For character is 1 byte. So in this case 0 into 1008, right? And so on, and that's how you can calculate the next index, right? So the important thing to remember is that when you create an array in the stack memory, it stores the first address of this element, like the first element's address, right? And through this address you can find the next element because they're stored back to back, right? You can easily use this formula to calculate the next element in the array. Okay, so what do we know about the array? So array has indexes that start with 0, right? Array has elements, right? Element has a size that is dependent on the data. If we're storing numbers, it's a 4-byte integer. If we store character, it's 1 byte, and so on. That depends on the data that we're storing inside this element. And then each array has a length. So length is basically how many elements we can fit in this array. So in this case, it starts from 1 and to 10. So there are 10 elements. Okay, so that is all about array. So we learned that they're stored in back-to-back memory. The element has a size and value, right? So each element has a size depending on the data type and the value. And arrays are stored in the heap memory, so their actual values are stored in the heap memory while the references are stored in stack memory, right? So that is a really important information about the array. Let's move on to different types. Alright, so in array data structure, there are two types of arrays, right? So there's one-dimensional array and there's a multi-dimensional array. So what is one-dimensional? So one-dimensional means we're storing arrays in a single dimension. That means in a row format, right? So when you create, let's say you defined it a variable called one-dimensional array, which is a single array. So you can consider this as a row, right? There are no columns, it's just a row. So you can say, okay, it has only one row, right? In multi-dimensional, you can have array within an array, and the array within an array are treated as rows, right? So this vertical elements, they're columns, right? So column 1, column 2, column 3, right? So if you want to find elements in one column, so let's say what is on this column, right? So 147. What's on the second column? 258, and third column 369. What's in the first row? 1, 2, 3. Second row 4, 5, 6, and row 3, 7, 8, 9. So that's how you define arrays, right? Let's take a look at some examples. All right. So here I defined some arrays here. So this is how we define the number array, right? In TypeScript, you put the type equals number. And then using new array keyword, you can create elements, right, like this. So be cautious while using new array syntax, because if you supply only single argument, that would take as a size instead of elements. But when you have multiple elements, then it will use them as an element. So if we console log this, you see that number array, it has 1, 2, 3 in it. And then we defined this Boolean type of array, which contains the Boolean data type, true, false, true. You can see that, sorry, I had to print Boolean here. Alright, so that's true, false, true. And this is a fixed size empty array. So you see here that when we created this array, we passed three elements, right? But when it has a single argument, it treats as a size of the array, right? So in this case, you get 5 empty spaces. You can see here it has 5 empty spaces, right? You can also create a blank array like this without using new array keyword. Also, along with the new array syntax, you can also call this will return you an array, and then on this array you can perform different array functions. So for example, you're calling the fill function, which takes 0 as a value, and it creates like 3 elements and then fill them with zeros, right? You can see it here. It has all the values are 0, right? You can also create a mixed type of array, and this is also called tuple in Python, right? Where you have different types in single array. For example, you have text, string, number, and Boolean, right? And when you output, you see them all here. You can also create arrays from iterator, right? So the array from function takes an array and then it destructures that into an array. So you get 1 2 2 2 3, and you can also create you use JSON parse function to pass a string in the array format, and then JSON parse convert that into an array, right? You can also use array from function, which takes an array, right? And then we're using object entries. We're passing an object here, right? So this is an object, and we are converting the object into an array, right? So this will create like multi-dimensional array like this, right? So you have arrays and then you have rows inside, right? And also matrix. So matrix is also a two-dimensional array where you have array and then you're passing rows inside, and that's the value here. And the last this is also a technique to create an array. So basically you are spreading the array in the new array. This is also called deep copy as well, where you're just destructuring existing array and trying to create a new array out of that, right? Alright, let's go back to our tutorial. We're gonna finally learn about different operations, right? So what are some basic operations that we can perform on array data structure, right? So first of all, you can update existing array, right? So how many ways you can update? I'm gonna be creating a separate videos for each operation in very detail. With the time and space complexity we're learning along, right? For each operation, like let's say if update, there are multiple ways to update the array, so I'm going to be covering all those operations and with their time and space complexity in separate videos. In this video we're just focusing on the type of operations, so we can perform update, we can access array, we can insert array, we can delete array, we can sort array, we can search. There are two types of searching we can do. We can perform linear and the binary. The binary works good with only sorted array, right? So when we are using binary search, we need to make sure that we sort the array first, okay? Alright, so this is it for today's video. Please subscribe and like my videos. Next I'm going to be creating my video on updating an array separately, and I have a playlist for arrays separately created. I hope you like this video. Please stay tuned for next videos. Thank you.